So, what happens when you take a classic piston engine and a rotary engine, and they have a baby? Well, you get this, a fascinating hybrid that promises to take only the best genes from both parents. And this isn't just some concept on paper, it's a real engine that's already taken flight. Let's get into it. Right out of the gate, there's the big question. What do you even call this thing? You might look at it and think, hey, it's a piston that rotates. Rotopiston. But nope, the official name is the Birotary. It's a seriously confusing name for what is a very, very cool engine.
Okay, so let's get formal for just a second. This is the Birotary engine. It is a one-of-a-kind hybrid, and it was designed for a very specific job, powering small aircraft. As you're about to see, every part of its design is brilliantly focused on that one single goal.
All right, time to pop the hood and see how this thing actually works. The real magic, the absolute key to the whole design, is its counter-rotating core. If you can wrap your head around this one idea, everything else about this engine just clicks into place.
So here's the core concept in a nutshell. You've got 3 pistons hooked up to a central crankshaft, kind of like a normal engine. But here's the big twist. The crankshaft spins in one direction, while the entire cylinder block that the pistons are inside of spins the other way. That's it. That's the secret sauce. 2 opposing rotations.
Let's break that down just a bit more. So step 1, the pistons drive that central crankshaft and it spins really fast. At the exact same time, the whole cylinder block is also spinning, but in the opposite direction and way, way slower. Then the propeller of the airplane gets attached directly to that slower moving block.
And boom! There you go. That's where the name comes from. Birotary. You've got one rotation from the crankshaft and the second rotation from the cylinder block. 2 key parts spinning in opposite directions. It's just a beautifully simple idea, but it has some really complex and awesome effects.
Okay, so you might be thinking, why? Why go through all the trouble of making 2 massive parts of an engine spin against each other? Well, it turns out this counter-rotation isn't just a party trick. It creates a whole cascade of incredible engineering benefits.
To really get it, we need to think about physics for a second. See, any spinning thing, like a crankshaft, creates forces that want to twist whatever it's attached to. But with the birotary, you've got another heavy piece, the cylinder block, spinning the other way. And those opposing forces basically cancel each other out. This makes the engine naturally balanced and makes the aircraft way easier to control.
You've totally felt this before. If you've ever gotten a fidget spinner going really fast and then tried to tilt it, you feel that weird resistance, right? That's a gyroscopic effect. Now imagine that in an airplane trying to make a sharp turn. The Birotary's counter-rotation pretty much kills that effect, and it does it without adding a single extra part or pound of weight.
And as if that wasn't cool enough, the design gets even more elegant. Because the whole cylinder block is rotating, you don't need a complicated valve train. That means no cams, no rockers, no springs, no valves. All that complex, heavy stuff is just gone. Instead, you just have simple holes or ports in the outer housing for air to get in and exhaust to get out. Okay, but hold on. Anyone who knows about rotary engines, like the famous Wankel, is probably shouting at their screen right now about one thing: sealing. Rotaries are notoriously difficult to seal properly, which causes all sorts of problems. So how does the Birotary deal with the Achilles heel of its rotary parent?
The solution is just incredibly clever. Look at this table. A Wankel engine puts its seals on that spinning, triangular rotor, where they get bounced around by all sorts of complex forces. The Birotary, though, has a perfectly circular rotor, which is just the outside of the cylinder block. This means the seals can be stationary, fixed in the outer housing, giving them the easiest job in the world. Just press up against a perfectly smooth, perfect circle.
So, we've got a balanced, simple, and really well-sealed engine. Sounds perfect, right? Well, let's talk about performance. Because the Birotary's design makes it a true high-speed specialist, and that comes with a very unique set of pros and cons. So, here's the big headline number you'll see for this engine: 10,000 RPM. That is ridiculously high, especially for an aircraft engine. But that number isn't quite what you think it is.
See, that 10,000 RPM is the effective speed. What's really happening is the crankshaft is spinning at 7,500 RPM one way, while the cylinder block is spinning at 2,500 RPM the other way. From the piston's perspective, it's like it's inside an engine spinning at the sum of those 2 speeds, which gets you to that 10,000 RPM figure.
This brings up a really fascinating question. Why on earth would you design an engine that needs to rev this high? And the answer gets to the very heart of the Birotary's design compromise. It revs high because, well, its mechanics allow it to, but also because it absolutely has to. It all boils down to this being a short-stroke engine. That just means the pistons don't travel very far up and down. Now, the pros of that are huge. Less movement means less vibration and lets you rev to the moon. But the cons are equally big. A short stroke means you get very little leverage on the crankshaft, so each little explosion of fuel gives you just a tiny push of torque. The source material has a perfect analogy for this. Think of the engine like a boxer. It can't throw a big, heavy knockout punch. Instead, to do any real damage, it has to throw thousands and thousands of quick, light jabs every minute. That's why it has to rev so high. It's making up for a lack of oomph with sheer volume. And here's the thing, this short-stroke design isn't really a choice the engineers made. It's baked into the very physics of the engine. Remember those simple intake and exhaust ports? Because they're fixed in place, the piston has an incredibly small amount of time to travel down and back up before the cylinder rotates past the next opening. Any longer, and the piston would have to move at speeds that would literally tear the engine apart.
So we have this super clever, high-revving, short-stroke engine. The theory is beautiful, it's elegant, but does any of it actually work in the real world? Let's put it head-to-head with one of the most popular engines in its class and see what happens.
And this is where it gets really impressive. Compared to the tried-and-true Rotax 912S, the Birotary makes the exact same 100 horsepower, but from a much, much smaller displacement. And it's physically a smaller package, too. That means it is incredibly power-dense, which is a massive win in aviation, where every ounce and every inch counts. With that kind of power density, the next logical question is, okay, when can I get this in my car or my motorcycle? And the answer, despite how clever this engine is almost certainly never.
You see, the very same things that make it a rock star in an airplane make it a total dud on the ground. It makes almost no power at low RPM. Those fixed ports mean it's only really efficient and happy in a very narrow power band. That's perfect for a plane, which just gets up to cruising speed and stays there. But a car? A car needs to accelerate, idle in traffic, and perform all over the RPM range, all things the Birotary is terrible at.
And really, that brings us to the final big idea. The Birotary isn't some magic bullet that's going to replace every engine out there. It's a niche champion. It's an engine that is perfectly, beautifully adapted for one specific job. And maybe that's the real lesson here, that the future isn't about finding one engine to rule them all, but about creating lots of wonderfully specialized designs just like this one.